Hi everyone, my name is Matt Bleifer and I'm a product manager at Tecton. Today I'd like to show you hands-on how a feature store like Tecton can help dramatically speed up machine learning application development time for operational models such as fraud detection. Let's dive in. So what makes developing ML applications like fraud detection so hard? Well, first, when it comes to getting feature data, we need to be able to access historical offline features for our model training. But then, when we deploy this model to production and use it for real-time serving, we need to be able to access the latest online features at low latency. Often this means re-engineering online pipelines in production, but this is an error-prone process that often leads to training serving skew. Next, our feature data may be derived from multiple different data sources. It could include batch data from data lakes or warehouses, stream data, or even request data, such as the current transaction amount or the user's current location. Lastly, these applications often have strict SLAs. Our online fraud predictions must return at low latency so that we don't keep our users waiting. Our system uptime must be consistent and reliable, and our fraud features need to be super fresh to adapt to recent events and deliver high quality predictions. These are some of the complex requirements that make developing these ML applications difficult, leading to high failure rates and long lead times, including months of development. This is where a feature store can help. A feature store helps data scientists define, deploy, fetch, serve, share, and monitor features for their ML applications. Using a feature store to develop feature sets can help reduce machine learning development time down from months to just minutes. Today, I'd like to show you a hands-on demonstration with Tecton of how this process works. We'll build and serve a feature set for a real fraud detection model. And to do this, we'll first productionize a new feature pipeline, then combine it with other features from the feature store that we found that perhaps others in our organization developed. Then we'll take our new feature set and fetch training data offline using the Tecton SDK. And then we'll fetch real-time feature vectors online at low latency that we could use to be able to pass to our fraud detection model in production. So let's get started. So let's develop a new feature for our fraud detection model. The first thing I'm going to do is take a look at the Tecton web UI, which is kind of like our portal for being able to browse, discover, and understand different data sources, feature pipelines, and feature sets that have been registered with Tecton. First, we'll take a look at this data sources tab on the left, where I can see that there's a variety of batch and streaming data sources that have been registered and are available for me to be able to build features off of. I'll take a look at this credit scores batch data source in particular and see that it contains users' credit scores over time. Now, I think I can use this data source to be able to build a feature that determines if a user has good credit or not. And so to do that, I'm going to hop over to what we call our Tecton feature repo. Now, the Tecton feature repo is simply a local set of Python configuration files that we use in order to define those data sources, feature pipelines, and feature sets that will serve to our models. In order to develop a new feature, I'll open up a file here and add some code. So this is what a feature definition looks like inside of Tecton. We define it as a view against some registered data source. This view can use various transformation languages, such as SQL or PySpark or Pandas UDFs, and it can range from simple one-stage transformations to a full complex pipeline of transformations. Here we can see we have a simple SQL statement that we're running against that credit scores batch data source as an input. We also specify the entities that this feature is indexed off of, in this case, a user, and that transformation type that we want to run, in this case, Spark SQL. Now, with just these three parameters up top and this transformation down in this function below, we actually have all the information needed in order to be able to successfully register this feature with Tecton and make it available for users to browse and even experiment with offline. However, because we want to use this data inside of our real-time production model, we also need to configure materialization. So here we specify that we want this data to be materialized to our online and offline feature store to support training and serving. We also specify how far back we want Tecton to backfill the feature data. And then once that backfill is complete, how often to continue orchestrating the compute jobs to calculate the latest feature values. In this case, we specify a batch schedule of 1 day. And that's it. Now I can take this feature definition and create a feature set for my model. To do that, we'll create what we call a feature service inside of Tecton. A feature service simply defines the set of features that we want to serve for a particular model. In this case, for our online fraud detection model, we will register a fraud detection feature service, and we'll include here a feature set that has both the new feature that we just developed, as well as some other features that are defined inside of the feature repo that perhaps we found through browsing the web UI. So now that we've defined both our feature service and our feature view, we want to register these features with the remote Tecton cluster. Now, in order to do this, I'll simply open up a terminal navigated to this folder and run Tecton apply. What this does is it tells Tecton to compare the local definitions that we have inside of the Tecton feature repo with what's registered on the remote cluster. Tecton will notice that we've developed both a new feature view and a new feature service and ask us if we want to apply this plan. We'll hit yes, and Tecton will get to work behind the scenes, backfilling our new feature data to the online and offline store, and then also productionizing a REST API endpoint that we'll be able to use to query online feature vectors in production that we can then pass to our model. If we hop back over to our web UI, we should be able to see that our new feature has been registered here. It's now not just available for us, but available for anyone in our organization to be able to discover here and leverage inside of their own models. If I click into this feature, I can see all sorts of metadata information about it. I can dig deeper and understand the full data lineage and pipeline that makes up this feature, all the way from my credit scores batch data source to the online and offline feature store where this data is materializing. I can also click into materialization here, where I can get information about the jobs that are computing these features and see that my feature is actively backfilling to that online and offline feature store. Lastly, I can see any of the feature services that this feature is a part of. In this case, we notice that this feature is a part of this new fraud detection feature service that we created and registered just a moment ago. If we click into this feature service, similar to the feature view, we can get a wealth of metadata information. We can see an example curl of how we can query this REST API to get feature vectors. And then we can see that full set of features that we're using to power this particular fraud detection model. And then, just like with our feature view, we can click in and really see and understand the full data lineage of all of the different feature pipelines that are powering this model. We can see this from our batch and streaming data sources here on the left, all the way through the feature store to these endpoints that will power our models for training and serving. So now that we've registered the new feature set and the new feature that we developed, we're ready to get data out of Tecton. So in order to get offline data out of Tecton, we'll use the Tecton SDK inside of a notebook. Here, the first thing that I'll do is load up a list of historical training events that I want to use in order to generate training data. In this case, we're looking at historical transactions from users at some particular point in time that were later labeled as fraudulent or not fraudulent. This is the set of training events that we want to be able to get all of those features that we defined for. Now, in order to get that feature data, we'll simply take this input data frame here, and then we'll also fetch that feature set by grabbing that feature service that we developed by name, and then passing both the input training event data frame and the feature set that we want to this get historical features call here. We'll run the cell, and what Tecton will start doing is enriching this provided data frame with extra columns representing all of the different feature data for every single training event. What Tecton will do is actually time travel on a row-by-row basis, and for each training event, for this user ID, for example, it will grab the correct feature values that were valid as of this point in time. And it will do this for each and every row we have here in order to properly guard against data leakage and build a historically accurate training data set. So there we have it. We can see down below that Tecton has built out our training data frame for us, containing all of the historically accurate feature values for this set of training events that we requested. We can now use this data frame to be able to train an offline model that we can later serve in production. Now, you may be wondering how we were able to build a feature set if some of our feature data wasn't yet done materializing to our offline store. Well, luckily, because Tecton has access to the underlying transformations for each and every feature, we can actually tell Tecton to compute some of these transformations on the fly directly from our raw data sources. This allows data scientists to rapidly iterate on and experiment with new features without having to wait for all of their materialization jobs to finish, greatly increasing their iteration speed. So now our final step is to see how we can get this data online from the REST API at low latency so that we can pass these feature vectors to our production fraud detection model. To do this, we'll hop back over to our CLI, and then we'll simply curl that REST API endpoint. And there you have it. We were able to get back a full feature vector at low latency that we can then pass to our fraud detection model for any given transaction that we want feature data for, and to be able to determine if it's fraudulent or not fraudulent. And that's it. In just a short time frame, we were able to develop a brand new feature for our fraud detection model, publish a feature set that serves feature data both online and offline, fetch training data offline to be able to train our model, and then get those real-time feature vectors from the REST API endpoint that Tecton productionized for us. We hope that with tools like this, data science teams will be able to much more rapidly develop new operational machine learning applications and bring more cool new use cases into production. If, like us, you're excited about the future of feature stores, come and chat with us in the Tecton and Feast Slack channel. Thanks for taking the time.